Welcome, ladies and gentlemen, to another episode of Mr. Balmer's YouTube videos. And today I present to you the eye of the solar system. What is it? It's an application which you can download. I will post the link in the description below of this video. And yeah, you can see here like our solar system. The sun is right here. Then we have the Earth, which we actually should start first. And we have Mars here, and there is Mars 2020. Yeah, rover, which is soon, hopefully, successful touch or land on Mars. So what you can see here in the with the numbers here is all the information which shows you the distance, the speed, the light time between Earth and the Mars 2020 rover. The distance, as you can see, is increasing because the rover is flying further away from Earth. So that's why this number is increasing, and the relative speed is, as you can see here, over 31,000, almost 32,000 miles per hour. One-way light time, that means the light it takes from Earth to reach the Mars 2020 rover. It is 3 minutes and 40 seconds, almost 41 seconds at the moment. That is how long the light travels from Earth to reach the rover, the Mars 2020 rover. So let's go from Mars. Let's go from the Mars 2020 rover to Mars itself. The distance is decreasing because the Mars 2020 rover is approaching Mars. And it is a little bit more than 30 million miles away. And as I said, the numbers here, as you can see, are decreasing. The light time from the Mars 2020 rover to the planet Mars itself is around 1 minute and 10 seconds at the moment. It's also decreasing, of course. The speed is 7,779 miles per hour at the moment, which the Mars 2020 rover flies towards the planet Mars. Yeah, this is some interesting information, because this information is what happens right now. That means, like, yeah, we get very accurate or quite accurate data here, hopefully. Yeah. Yeah, so we can change the time, the data, real time. See, you have November the 19th, 2020, the time. This is the time which I have here, actually in Switzerland at the moment. Let me check if this is accurate. I think, yeah, it is. It should be. And we have more additional information because we can zoom in, we can zoom out. Let's go for a moment to the Mars 2020 rover, and that's what it looks like in the virtual environment, flying towards Mars here. So yeah, let's put it that way, and it's going this direction. Actually, like this direction to then land somewhere. Actually, hopefully, exactly on Mars where it should. So this is the Mars rover is inside here. This is the heat shield. The communication, there are some solar panels, I think, as you can see here, and pointing towards Earth. So here almost. So this is this is what it looks like. Let's go to Mars for a moment, and here we have Mars. So it should, we see on Mars itself, we see other aircraft and spacecrafts, or rovers actually. There was the Opportunity landing site here. There is Marvin. This is a satellite which flies around Mars. There is the Mars Reconnaissance Orbiter. Mars Reconnaissance Orbiter. And here we have Mars Odyssey, Trace Gas Orbiter. Mars has also Phobos here, Deimos, the Mars Orbiter mission, Mars Express, all measuring different things. We have the InSight landing site here and the Curiosity landing site here as well. So we will have hopefully soon another rover, the most advanced rover which was ever built, the Mars 2020 rover. There's the Mars Express here. Okay, so yeah, that's it. Let's go back. Let's zoom out, and here is the Mars 2020 rover, and coming in, approaching here, and someday somewhere here it will hopefully land on Mars. So you can see the data is getting closer, going down. Yeah, interesting stuff. Yeah, good. So you can look also different, you can see other different objects, other planets, Jupiter, Saturn. There is Uranus, Neptune, Pluto here. We have Horizon spacecraft, which is flying also away from Earth. And we have other aircrafts which started in like 1977. Yeah, like the Voyager 1, which is the furthest known object or furthest human-made object away from Earth. The furthest object human-made, the furthest human-made object away from Earth. Let's check in here. Mars. So let me go in and go to Earth. Look at the distance here. It takes more than about half a year to reach it at the moment. Yeah, from this little distance, from Earth to Mars. Awesome, huh? So let's go like this. This is the Sun and Earth. Okay, let's go that far out here. And no, let's go even further far away. Okay, let's measure the distance going out to Voyager 1, which is already in interstellar space. That means already out of our known planets here, of our solar system, but not outside of the Milky Way galaxy, because the Milky Way galaxy is much bigger. So, but outside of our system here, as to be said, yeah, our system here, interstellar space, 14 billion 110 million 917,000 and 700 miles away from Earth, and flying with 87,340 miles per hour away from Earth. So Voyager 1, then we have here, as you can see, Voyager 2. Let me see the perspective. Voyager 1 is flying this direction, and Voyager 1 is flying this direction. Then we have Pioneer 11, or actually I should probably start with Pioneer 10 flying this direction and Pioneer 11 flying this direction. So this direction and this direction, almost like the opposite. Yeah? Look at this. We cannot even see the sun and Earth here or Mars, right? It's like on that little spot, and they flew like that already away and flying further and further. That's why the number here is increasing all the time. I think this is 79. Voyager 1 is flying, I think, something like 91. Let's check that for a second, because I think it's even flying faster. Voyager 2 is even flying faster. Let's check that. So yeah, 91,115 miles per hour flying away from Earth. See, you can count the seconds. Another 100, another 100, another 100 miles, not kilometers, miles. So wow. But what is that? It's fast, as we know, but it's very slow, very slow, very slow in terms of the universe itself. Yeah, so that's why we have objects from here. That's little spot somehow, and Sun and Mars, and they flew almost, or they already flew like this. But what is this when I zoom out like this? How about this? How about flying here? How long does it take? 77 years. No. Since 1977. How long is that? Let's calculate. 23 years to 2000. Plus another almost 21 years. Let's say 20. So we have 43, like 44, almost 44 years flying with that speed, and it is just here. Yeah. How about double? Here, yeah, here. How about this? How about here? That we can see that one. How about here? Yeah, how many thousands of years it takes just to reach here? And how about trillion times further away than that? And that again, high trillion times further away than this. What do you think? We need to fly with much faster than light speed to go somewhere, in this universe. Is that another sun? Is that a sun? A star? A star? Sun? Star? Yeah. What is it? This is... And how about this times 999 trillions? And that high 999 trillions, and that again high 999 trillions, and that 999 trillion times high that. What do you think in the distance? And this would be in comparison, this one here, would be in comparison. Oh, this would be in comparison from Earth to Mars 1. How about this? This is already X times here. 43 to 44 years flying with almost 90,000 miles per hour. We go nowhere like this. What is this in times what I just said with the numbers? When this was just like, when this is just 1 from Earth to Voyager 1 now, when this is just 1, how about the numbers I told you? How many times? How big is the universe? Nobody knows. But let's go back, instead of philosophy, to reality. Yeah, let's see what it is here. As I showed you, this is a representation, a virtual representation of the real stuff out there which we have far away from Earth and even close, but we have other sources that have much more objects in space, mostly near Earth objects or low Earth objects, LEO, or satellites actually, or just around our little planet. Here, let's go zoom in to Earth. Let's zoom in, and what we see here, the Earth, with some stuff around it. Of course, there are thousands of more stuff. This is just like some things, some information, some part of it, as you can see here, something. But there are much more of satellites and Earth observation objects. So let's put that in the right way. Let's put that in the right way, because I think here we are, Switzerland and America. There's Africa. There's Australia. They have already nighttime here, the Asia, yeah, with China. And yeah, so okay, let's see how it is. This is real time. So where is the ISS? Here it is. Here's the ISS. Here's the ISS. The ISS is currently over Russia. Let's see how fast it flies. Yeah, 7,143 miles per hour. Seems very fast. As you can see, it's moving. Let's zoom in a little bit. You can see that it's moving. Oh, so you see it's moving fast. It's already fast, but it's very slow. Yeah, what is it? Probably one of the fastest objects. It's flying. See, this is where it is actually a real representation in a virtual world. 263.5 miles distance between Earth and spacecraft. And currently, right now, 7 astronauts are living on the ISS. You can zoom in. Oh, we have the ISS here. Yeah, well, awesome. It's moving. So, see? And this is a human-made object. So, looks quite good built. Good. Awesome. And as I said, it's real time. So you can see data. Let's do that again. Let's do that again. Tack. Hey, where are you? Oh, here. So let's zoom in that a little bit here. So we have it. Okay, so that's okay. That's okay. So we have, let's put it here, moving with that speed. You can zoom in here, solar panels, modules. Awesome. So in that segment here, there are people built that, hey, people built that in space. Isn't that awesome? But there's a new station. There are new stations which will be built right now, and then tourists can go up. There's I think a film which they make on the ISS soon with real actors. So yeah, and all other stations will be built. Yeah, that's good. So let's go back. Let's go back. And here we go. Here we are again. It's already almost fly over Russia right now. So yeah. All right. Let's focus on Earth. That's okay. So this is Earth, but there are much more objects which fly around. I showed you that in another video. If you look, stuff in space. But I will post a link to this, to the Eye of the Solar System. It's a free program you can download and then see some parts, some stuff, something what's going on in space. So let's focus again. Solar system. Yep, about like this. So the sun, Earth, the sun. Then we have the Mars 2020 rover approaching Mars soon. I think around in February 2021 it should touch down, should land. And for the first time the rover has also an helicopter on it, which will fly autonomous and conduct its scientific research, scientific stuff. Let me say it that way for a moment. You can all check that up. You can all check the data on the internet of NASA and other websites, of course, and see videos on the internet. So yeah, someday we will fly to the moon. Let's see, where's the moon? Where is the moon? There is the moon here. See? Moon. Okay, let me show you that for a moment also. The distance between Earth and the moon. Okay, here we go. It is 230,243.9 miles at the moment, the distance. And it's increasing at the moment. It's a little bit further, flying further away, but it's going roughly around the planet Earth, yeah, so to say. The one-way light time is 1.24 seconds at the moment. That means one time the light takes from Earth to reach the moon is 1.24 seconds. And to fly back the same time at the moment in this situation here. And you could and should calculate with an answer back in about 2.48, so about in 2.5 seconds you should receive an answer. So if there is a so-called like live video chat or a call or a video conference in the future, the delay would be probably 1.25. Hopefully they can bring it down somehow, but probably 2.5 to 3 something. May I hope it's much lower. But yeah, you just have a little delay. But yeah, you can communicate, chat, you can talk, you can have almost like a video or a video conference. That should all be possible in the future. because there is already an optical or laser connection downlink with some hundreds of gigabytes per second. As I've seen, you can also check that up. So in the future we will have posts on Mars and live on Mars. You can fly in the future like as a tourist to the moon, visit the moon, fly around the moon, or visit the moon and then coming back, like you do that with airplanes to fly in other countries to have your holidays. And hopefully in the future you can also visit Mars, which is a little bit a longer trip, as you can see. And in a good situation when it's near, because here it would be a little bit further, you can see, between the circle of Earth around the Sun and the circle around the Sun by Mars. As you can see, the circle of Earth around the Sun, the circle of Mars around the Sun is a little bit different. So the distance here is the closest, where you have to start aircrafts or maybe holiday trips in the future. Yeah, we're actually going to Mars to live there and work there. Yeah, in the future. So here it takes longer, and this is like 6 months trip here. So that would be 8 to 12 months probably, could be. So I guess it would be here, and that appears every 4 years, something like that, or every 2 years, every 2 to 4 years, I guess, something like this. Yeah, so I need to check that again, but I think something between 2 and 4 years that you have the opportunity. So I think every 2 years, I guess that should be. But let's go further. I will post some information in the link in the description below. I will post some link in the description below. So yeah, in the future we will also fly to Mars and live there. But yeah, this is the best what we try to achieve at the moment. So hopefully AI in the future will help us to make much more advancements, and that we can go even further. How about to Jupiter someday, and Saturn probably, if that is possible. I mean, who knows? Well, to Uranus, likely not. But or to the rings, or some kind of asteroids, or a lot of things may be possible, and is possible, I think, in the future. Maybe we fly to Pluto someday. Who knows? Like that spacecraft already, like Voyager 1 already flew out into interstellar space. I mean, if you can fly, let's say 100 times faster, you can reduce 43 to 44 years, 100 times less. Then it should be possible. Like almost like if you would fly from Earth to Mars when it's around here. Yeah, so let's calculate that precisely, absolute precisely. And now this is why I want actually that you can see that the Mars 2020 rover will soon, that should be in February 2021, land on Mars and start scientific research there. Yeah, its mission. Good. So all we know at the moment for the most people is this little dot here. But there is much more to discover. Okay, thank you very much for your attention. If you like the video, you can subscribe, Click on the button to subscribe if you like. There's a little bell to get notification when there's a new video which I upload. If you want that, you get notified. You can like it, it would be appreciated, and you also can share my videos to all the people you may know. That is also very much appreciated. So thank you very much for your time, for listening, and as always, peace in.